So 25 times 12. Show us the way that you solved it. We have one example that did counting by 25s. I'm sorry, I can't hear you because there's some people in here that are making some random noises. Speak really loud. Okay. And push the pen kind of hard on the board and then it won't miss the circles. Okay. Can someone show us another way that they solved 25 times 12? And pick up the red pen and explain while you're solving. Okay. Okay, are you doing 5 12s or are you doing 25 12s? Count how many 12s you just wrote up there. Wait, take a step back. I'm confused. You just told me that you were writing 5 12s. And you wrote the number 5 12 times. So are you writing 12 5s or are you writing 5 12s? Okay. Okay. Keep going. Okay, and what does that equal? 16, okay. So that gives us 5 times 12. What else do we have left in our problem? 12 20s. Okay, so let's see that. Or is there a way that you can solve that without having to add 20 12 times? Okay, you can add it. Let's see. Or could you just count for us out loud? Can you count for us out loud by 20s? Good. That's our first 5 is 100. Keep going. Sure, just keep going out loud. Okay, that gives us 200, and that's 10 20s, and we need 12, right? So keep going. We've got 200. Okay, so 240. Write down the number 240. So we know that, that's 20, yeah. We know that 20 12s equals 240. So what else do we need to do now? We've got 20 12s, and we've got, okay. And what will that give us? Okay. Does someone have another way that they solved it? Because so far the three ways that we have seen have been very different. Okay, what I'm going to do is before you pick up the pen, I'm going to move it, and you're going to do it in green. So I'm going to move some of this stuff so that we can keep it up here. That's all right. I'll move it. Okay, and can you show us another way to do it in green? So did you do kind of what was up there in blue? Okay. So you knew that 4 goes into 12 3 times, so you did 4 times 25 3 times, so you did 100, 100, and 100. Good. Okay. When he's writing the rest of it, did anybody do it differently than this? Lydia, can you come up and you're going to do it in black? Okay. It's okay. It's okay. You already started writing. It's fine. Okay, you get 25 times 10, and what does that equal? Good. Very good. 300. Now, it looks like we came up with 300 for our answer each time that we solved it, but every one of those was solved differently. And none of those ways that were actually solved up there is what we call the traditional algorithm, which is what I learned growing up as well as your parents growing up. Does anybody know how to solve it that way? Yes. Did you do it the vertical way, Andrew? Okay, Andrew, go up and let's see your way. And I'm gonna move to a new page just so we have room. And can you show me 25 times 12, Andrew? Yeah, you can't put your pen up or your book up there because it'll touch the board. 25 times 12. Okay. So you threw in algebra. I'm going to say, this doesn't look like what I did when I grew up. Because I don't remember ever writing an addition symbol in my solving of it. So are you going to chunk a whole bunch of 25s together? Do you have 6 groups of 225s to make 50, and then you're going to add all those up to get your answer?
Yeah, and then I added all of these together and got 100 for each of those, and then 100 for each together, and then added 2 of those between 2 of those.
Okay. So you kept adding them together until he got his answer.
What did you do? What did you do that?
Now, I'm going to write this problem. And this is the way that I actually learned it growing up. And I'm guessing most of you don't know this method. And what I'm going to do is I'm going to write it out the way that is called traditional, and I'm going to write it out another way to actually show the problems. But what we did was we would do the ones place times the ones place, so 2 times 5, and that would give us what we call 10. We put the 1 up here. Okay? Then you're going to do 2 times 2, which is really 2 times 20. And 2 times 20 gives you 40, and we add the 1, which would be
What?
okay.
That doesn't make no sense.
That doesn't make any sense. Would it be? Well. Let's see. And then we're going to drop our 0 down because we're moving to a new place value. So 1 times 5 or 10 times 5 is 5, right? Okay. We're going to scratch this out because we're no longer using it. And 1 times 2 gives us 2. And if I were to then add these together, I actually get my 300. And that's how I learned it growing up. Okay? And for some people, they say that doesn't make any sense. Well, I'm going to show it another way real quick. 25 times 12. And I'm going to show the actual 4 math problems that are going on. The first one is going to be this right here. 2 times 5, which is 10. Okay? So I'm going to actually write 10 here. Now, the second problem that I'm going to do is 2 times 20, which equals 40. And I'm going to write that answer right here. Okay? Now, my next problem is going to be 10 times 5, which equals 50. I'm going to write 50 here. And the last part is going to be our 10 times 20. That equals 200. And if I were to put that here and add up all of my numbers, you're going to see that I end up with 300. Now, if you look at this, this is one way to solve the problem. This is one way to solve the problem. This is one way to solve the problem. And then on here, we have 1, 2, 3, 4, 5 more ways that we came up with our answer. So a total of 8 different methods to get the same answer for the exact same problem. All are correct. However, some took less time than others to actually solve, as well as a lot less room on a piece of paper. Okay? Okay, very quietly, head to your seats. And clear off your desk.